one of the things that we have to be able to do is determine the number of solutions just given the equations. In our textbook on page 171, you see this box that tells us the number of solutions. Equations that have the different slopes have one solution. If they have the same slopes, sometimes they have 0 solutions. That is, if they have different intercepts. And if they have the exact same intercepts and slope, then there are an infinite number of solutions. So the easiest way, or the easiest kind to determine, are those that have different slopes. Let's look here at our examples from our textbook, or from our test. In this first case, the slope of the first equation is 3 over 1, because you change the sign. The second equation is negative 3 over negative 1, which is the same 3 over 1. So they have the same slope. But if you notice, they have the same slope. In the first case, the intercept is negative 5, and in the second case, this intercept is, well, actually, that's not the intercept. The x value, or the c value, is different. So the equations have the same slope but different intercepts, and so these would have no solution. Next one. Classify the number of solutions in this instant. Well, the slope of the first one is negative 1/2. Remember, if it's in the intercept slope form, it's just the coefficient. And in the second case, it's 3/2. Those have different slopes, and so they would have one solution. Next one. So our first step is always to determine what the slope is. In the first case, the slope is negative 5/2. In the second case, it's negative 20/8, which it reduces down to negative 5/2. Halves. And if you notice, when we simplify this, they get the same slope. So it's either going to be an infinite or a 0 number of intercepts, or of solutions. The intercept in the first case is negative 25. And if we divide the second one by 4, because that's what we did in the first case, we get 49/2, which doesn't come out evenly. And so we would say they have different, they have no intercepts because, or they have no solution because the two lines are parallel. Next one. Classify these equations in the first case, the slope is 1/5, and in the second case, the slope is negative 2/10, which negative 2 over negative 10, which is 1/5 also. So the slope is the same. And the intercept in the first case is positive, so B is 17/5. In the second case, B is negative 30. I'm sorry, just a second here. Negative 17 is the intercept in the first case. In the second case, it's negative 34 over negative 10, which is positive 17/5. So those two have different intercepts, and so we would say same slope, different intercepts, we would say they have no solution. Number 5. In these two cases, they aren't in the intercept slope form, and so we have to find the slope using a different method. The slope, remember, in an standard form is take the x coefficient over the y coefficient and change the sign. So that's the slope of the first line. The slope of the second line is the same, negative 5 over 2, but change the sign. So the slopes are the same. Intercepts are different, and so they are parallel lines. In the second case, well, those two are the exact same lines, so we would say they have an infinite number of solutions. Let's see if we can get this one to have something that doesn't look the same. There we go. Let's try this one. The slope in the first case is 4 over 5, change the sign from negative to positive. In the second case, it's 12 over 15, change the sign. 12 over 15 is 4/5 when you divide everything by 3. In fact, if you divide the second equation by 3, you get the first equation, and so they have no solution. This is 2.8.C.